Welcome. In this session on natural deduction, we'll explore why we need a richer language than the one that was given to us in propositional logic. Let's begin by considering a classical syllogism. So let's consider this syllogism, and this one is due to Aristotle. And Aristotle was a student of Plato, and Plato was a student of Socrates. And Aristotle reasoned out that there were a number of syllogisms which were three-line, we would call them sequence or proofs or arguments, that he considered to be definitely true. And an example of one of them is all humans are mortal, which means that all of us eventually die, and Socrates is human. Therefore, Socrates is mortal. Now, suppose that we tried to put this syllogism into predicate logic. Well, we might pick symbols. So we might, for example, say the first one is human implies mortality, and being Socrates implies human. Therefore, being Socrates implies mortality. And although this can be reasoned out quite directly using natural deduction, so for example, the moment we see this as the conclusion, we would want to open up an implication introduction box. Given this, yes, we could prove it, but somehow that isn't capturing everything that we want. That is, simply saying that Socrates is human, that English statement isn't well captured by this little piece of logic. So we could try adding predicates. And this is a powerful notion in mathematics and logic. And a predicate is a map of an object to a truth value, which is t or f. And again, in logic, there's no question if a predicate applies to an object, it is either t or it's f, and there's no in between. You can't say and a maybe. In our kind of logic, in this natural deduction, you have to make a choice. So we could say that this is actually a statement in our meta-logic, but for now we'll just understand that what that means is that we have this map. So we could try re-expressing this using them. So for example, we could say that h of x means that x is human, and we could say that m of x means x is mortal, and we could say that s of x means that x is Socrates. And what we could then try, based on that, is we could try replacing these propositions with predicates. So we could try, for example, saying if x is human, then x is mortal. Well, that's capturing a lot more, isn't it, than what we had before. We could also say that if x is Socrates, then x is human. And that would get us part way, and we would then say, therefore, if x is Socrates, then x is mortal. Now, a problem that we see immediately in this is that this is also not capturing everything that we have over here. For example, this statement, all humans are mortal, isn't really captured by this formula. And for this one, well, S of x materially implies h of x. Well, suppose x is a dog, right? So if x is a dog, then x is human. Well, that material implication might hold, but something definitely isn't right there. So none of these, so this is a good step in the direction, but it's not capturing everything that we want. So let's try adding, and these are called quantifiers. And we know these from mathematics already. Now we're going to introduce them in logic. Although really, it came the other way. Really, it came from logic and then it got put over into math. So we'll say, we'll put it in quotes, for all, or for every, or for each, depending upon exactly how you want to do the translation. We'll use the upside down A symbol, and for there is at least one, we'll say there exists. We'll use the backwards E symbol. And now we can get a little closer to these. So now what we could try is this. Instead of saying all humans are mortal, what we could do is say for all x in, we'll formalize this later as our universe of discourse, but right now we'll say for all possible x, if x is human, then x is mortal. And that seems to get a lot closer, doesn't it? Now let's try translating Socrates, and we don't want to say for all x, if x is Socrates, then x is human, because that gets us into this whole problem about what happens with dogs, etc. So let's try there exists an x such that x is Socrates. Well, what do we now mean? Well, one of the marvelous things about the English language is the inherent ambiguity. It's a problem when we go to translate it, but it's beautiful for poetry and other expression. And now, when we say Socrates is human, our translation would be there exists an x such that x is Socrates, and now we're going to assert, and in addition to being Socrates, x is human. And now we're getting much closer. Then what we want to do is say therefore, and now we're not sure at all how to put that last sentence. That is, do we mean that something is Socrates and something is mortal? Do we mean that if something is Socrates, then something is mortal? Well, let's not fill this in right now. What we need to do is we now need to take our understanding, this is our motivation, and in subsequent sessions, what we'll do is we'll start to explore these in greater detail. And one of the first things we'll do is we'll define a formal language that we need for this predicate logic.